Hi everyone, and I'm happy to welcome you on the one more day of Vectara Hackathon, Rock LLMs with your own data. I'm excited today to host an announcement talk with Ofer and Forrest from Vectara team, and they are going to announce you new updates from Vectara. I don't want to say more because it's an exciting announcement, so I want to leave more for Offer and for Forest. So all I want to say is stay tuned. Feel free to use Twitch for comments, discussion points, anything you want to ask, you wanted to maybe know more, any questions regarding your projects. And as well, I would love to announce that in following days, we'll have Q&A sessions where you can basically talk about your project and get some maybe comments, maybe just a review on your project or better ideas how you can make it faster and better. So tomorrow we'll have a Q&A session with our mentors where you can talk about your team formation, your ideation process and submission. And day after, we'll have a session with Vectara team where you can actually talk more about the technology and get some insights on how to make your project better. So use it for your best. And now I'm happy to welcome you to the announcement from Vectara. And we have Ofer with us and Forrest. Guys, happy to have you here today with us.
Thank you, Alessia. Hi, everyone. We wanted to do this session today to announce a very important launch we just did yesterday. As many of you know, in the world of RAG or retrieval augmented generation, one of the most important pieces is the ability of the LLM that sits at the end of the pipeline to take facts, pieces of text that gets extracted from the retrieval engine, and very consistently make those and kind of form those through the work of the LLM into a summary or a response. And it turns out not all LLMs do that equally well. There's some that hallucinate more than others in that sense. And it's important to be able to understand that piece. So yesterday we announced work that has been undergoing in our machine learning team for a while around a hallucination evaluation model, which we call HEM, which allows us to measure that and be able to decide which model is best for you. So this is not particularly something that is important as a new feature for this hackathon, but I think it's important for everybody who's interested to learn about RAG and about hallucinations and about the whole space. So we thought it'll be an interesting topic to talk about and share. This was, by the way, presented also featured in the New York Times yesterday and this morning in the paper version, and a lot of discussion about in the industry about this. So to give you more details about hallucination in general and how this helps kind of measure and quantify hallucinations better, I'll pass it over to Forrest. Forrest, we can't hear you.
Okay.
There you go.
All right. Can you guys hear me?
Yep.
Okay. All right. Let me start my presentation. And here we go. All right. Hold on. Let me do a desktop sharing instead of sharing part of it. Sorry, give me a second. How can I share my entire screen? Okay. Yes, share my entire screen. Okay. All right. So thanks for coming to my talk. Today I'm going to talk about the intractability of summarization in RAG. So this is today's agenda. We'll first talk about what hallucinations are. Then we go over the causes of hallucinations. Then we talk about why hallucinations are difficult to be catched. And finally, most important part, tell you can let Vectara's hallucination evaluation model, or HEM, to help. Let's begin talking about what hallucinations are. You probably heard about the news that some lawyers use ChatGPT to prepare their case materials and submit to the judge. But it turns out that ChatGPT made up a lot of cases that do not exist. That's why those lawyers got humiliated and got fined. So that is what we mean by hallucination. Hallucination is when a language model makes up things ungrounded. Such ungrounded, it could be ungrounded to the prompt, which is the user information given. We'll talk about in the next 2 slides. Or it could be ungrounded even to the training data. Usually, when the language model says something which is against the common sense, such as the capital of France is Berlin. Now, hallucinations are a big problem for large language models, especially in retrieval augmented generation, or RAG, which contains an important step called summarization, because it is risky to give summaries that may contain information inconsistent with the source to your users. However, Vectara's HEM can help. It predicts the likelihood that a summary is hallucinated, and you can decide whether to present this summary to your user. And to be a little bit more technically precise, by hallucination, we mean factual inconsistency between the output text and the source. So before we talk about the importance of hallucination detection, let's talk about what a RAG is. That's the central business of Vectara. So RAG stands for Retrieval Augmented Generation. So it is a technology used to answer queries from massive amounts of documents without fine-tuning. So RAG usually has 2 stages. The first stage we call it retrieval. Suppose you have a query that says, what is Splenda? Then you have a bunch of documents about lots of knowledge. In the retrieval stage, we will find out documents that are most relevant to the query, what is Splenda? And then from those fetched or chosen documents, we go to the generation stage. In the generation stage, a summary will be generated by extracting information from such chosen documents to best answer the query. For example, expected summary is Splenda is a sweetener. And this generation stage, or this summarization stage, is where hallucinations could happen. Let me show you a live example. This is a live example we extracted from a RAG benchmark. The query is, what is a Splenda? And there are many, many documents provided to answer this query. And in a citation summarization task, one LLM made by a very big company in Silicon Valley generated this sentence, that Splenda is the brand name for saccharose, a non-nutritive sweetener. And it cites source 1. So this is our source 1. But if you look at this source 1, it says nothing about brand name or saccharose or even the word sweetener. It does not even say anything about whether it's nutritive or not. This source 1 is about the safety of it. So this is a case of hallucination. And indeed, here we see a live example that hallucinations happen in RAG. So before we can tackle hallucination, let's analyze the causes of hallucinations. Hallucinations could be caused by many reasons. The first reason is overfitting, which is a common problem of any supervised machine learning model. By overfitting, we mean that a model behaves like outputting what it memorized from the training, instead of generating the output in accordance with its input. This is the case we saw earlier in the Splenda example. The language model memorized that Splenda is a sweetener, but while the given document actually talks about its safety. Another reason of hallucination is randomness, because in text generation, we have many random parts, for example, the beam search. So the randomness could probably pick something that is unfaithful to the input document. Lastly, hallucination could happen because the language model itself was trained with noisy data. So they're destined to hallucinate. I will show you in the next slide. For example, XSUM is a widely used dataset for summarization research. The curators of the dataset crawl news articles from the BBC website, and it treats the first paragraph in every article as the summary, and the rest of the article as the input document. Do you see something interesting here? What if the first sentence contains information that does not repeat in the rest of the document? That is the case in this random sports news I found on BBC website. So here, on the first sentence of this news article, there's one entity called the Manchester Police. But Manchester Police was not repeated in the rest of this article. So you can imagine, if we use this piece of news article to train a summarizer, the summarizer will be forced to make up the entity name Manchester Police in order to generate the expected output. And if we use this model on other news articles, it will be forced to make up some entity names. That is what we mean by a noisy training data leads to hallucinations. Now, hallucinations are difficult to tame, also partly because of their diversity. Let's look at different types of hallucination types. For example, suppose we are given this news article. It talks about when was Ebola developed, how long after the initial outbreak, and it talks about the scientific steps to develop a vaccine and whether how soon FDA is likely to approve it. Now, a summary. This is a summary generated by a language model. It says the Ebola vaccine was rejected by FDA in 2019. So obviously, this summary is unfaithful to the input document because the input document says the Ebola vaccine was actually approved by FDA. So this kind of error, we call it relation error because it misconnects the relation between the Ebola vaccine and FDA. Now, same article, let's look at another kind of error. It's called entity error. So the original document says the Ebola vaccine was approved by FDA in 2019. But the summary, the inconsistent summary says the COVID-19 vaccine was approved by FDA in 2019. That the entity is wrong from Ebola vaccine to COVID-19 vaccine. Now let's look at another more complicated errors. The summary says the first vaccine for Ebola was approved by FDA in 2019. They say a vaccine for COVID-19 is unlikely to be ready this year. So who are they? You might interpret they as FDA, right? But if you look at the original article, it says scientists say a vaccine for COVID-19 is unlikely to be ready this year. So this kind of error we call it a co-reference error, when a pronoun will be interpreted to a different entity in a summary than in the original article. Lastly, let's look at a more complex kind of error. It's called discourse link error. So the summary says, to produce the vaccine, scientists have to show successful human trials, then sequence the DNA of the virus. Hey, you might already think this summary is problematic, right? How can we do human trials first, then understand the virus? So this is because the information in the original article got flipped in the order. So if you read the original article, it says, to produce the vaccine, scientists had to sequence the DNA of Ebola, then identify possible vaccines, and finally show successful clinical trials. So these are the 4 types of hallucination errors. There are many other types of hallucination errors. Due to the time today, we're not going to go over them. Now, let's talk about the intractability of hallucinations. By intractability, we mean that it is actually very difficult to detect the hallucinations. First, let's look at the numbers. The first column lists the state-of-the-art methods for several hallucination detectors. They were published in the past 3 years. And the 6 columns are 6 different data sets. And the numbers shows that the accuracy of each model on each data set. If you look at the numbers, they mostly range between 50% and 70% in terms of accuracy. So that's not really good enough, which means around like 30% or 50% of the summaries will be misclassified as consistent, will go under the radar. And if we break down those non-error rates by the types of hallucination errors, we'll see even in some cases, our models will perform even worse. For example, SAMEC and MFMA, they are the 2 best models on 2 best hallucination detectors. But their error rate on co-reference error and discourse link error is above 50%, which means it's even worse than flipping a coin. Now, why? Why it is so hard to build an accurate hallucination detector? Now, let's look at how the SOTA, the state-of-the-art detectors, are built. Many of the SOTA approaches use token-level operations to synthesize artificially hallucinated summaries from gold summaries. Basically, gold summaries are human-written. They are very consistent with the original document. And those SOTA needs to in order to train a hallucination detector, they need to have hallucinated summaries. And then they generated so-called artificially hallucinated summaries by manipulating or by perturbing the good summaries. For example, factor CC perturb a good summary by swapping entity words and pronouns and inject words and rewrite sentence by paraphrases. MFFA does something which is quite smart. They mask out entities and noun phrases in the input article and ask the summarizer to summarize the information with some certain information masked. So therefore, the summarizer is forced to make up information because it's not a given. So, however, such token-level operations are very hard to resemble many error types aforementioned. If you recall certain errors here we see, for example, understanding the sequence of the vaccine development and then reorder them against a scientific order, it's very difficult to mimic that, to reproduce it. So that is the reason why the SOTA cannot track a hallucination very well. However, Vectara's HEM is come to help. Vectara's HEM was just released yesterday, on Monday, and you can find it by going, it's already shared on Hugging Face with the rest of the world. It's a totally open source model. The HEM model does not use artificially hallucinated training samples. Instead, it was trained using actual human labeled summaries generated by real LLMs. And that's why it can excel really well on real life examples. Now, let me give you a quick demo on how to use this model, and let's see whether it is effective. So I created a Google Colab notebook to show you. And first, I begin with some data. I call them example pairs. So remember, in summarization, you have the input article, and you have the summary. So I have many pairs of article, and summary. Now, for example, if we look at the first one, you can tell it is inconsistent, and it is a discourse link error, because the original article talks about two kinds of fish, the goldfish and the koi carp, and talk about their weights and their length. However, the summary says the goldfish links the weight of the carp with the fish goldfish. So that's why it is inconsistent. Okay, and here I put example which I just talked about the vaccine. Okay, the original article says Ebola vaccine was approved by FDA, but the summary says the COVID-19 vaccine was approved by FDA. Now, in order to use our HEM model, you need to use a special token, SEP, to separate the article and the summary. So I just prepared this, I just converted this dictionary into the format for our Hugging Face query format. So for example, you look at the fish example, we would have a one string separated by the special token SEP. Before that, it's the article. After that, it is a summary. And then we could query to the Hugging Face inference endpoint and make sure you load our model, right? So then we can make a query. And after the query is done, we can look at the output. So our output contains a field called the score. So the higher the score is, it's unlikely a summary is hallucinated. And the lower it is high hallucinated. So this one shows it's very, very high hallucinated, right? And what is that example? That's a third example. That's the vaccine example. It is very, very hallucinated, okay? Okay, all right. And let's play some interesting thing here, okay? So you might see something interesting. Why this hallucinated one has a high score? It's because this is a, let me give it a try. I think earlier when I was playing it, so if it's 2 kilograms, then it is not hallucinated. So we're supposed to see a high number, okay? And if I change it to a different weight, to the weight of the carp, it should show as hallucinated. Yeah, so it is hallucinated. You can see this number dropped from 0.6 to 0.005, which means it's very hallucinated. So you can, so let's do something interesting. What if I change 8 kilograms to 6 kilograms. So it's not the weight of the goldfish nor the carp. What's going to happen? Our model, oh, hold on, it's loading. Give it a while to load. Okay, here we go. You can see it's still hallucinated. I mean, our model still judges the summary is hallucinated. Despite that, this is the case. Now, even if you change it from 2 kilograms to 2 pounds, let's see what will happen. Oh, it is still hallucinated. See, that's how great our model is. It can even tell the difference between 2 kilograms and 2 pounds. All right, so that's pretty much the demo I want to give. I'll leave the rest of the time for questions.
I think this was. Go ahead. I was just gonna say, Forrest, thank you for that presentation. I think a good demonstration of how the HEM works to detect hallucination. You know, as we look at this in Vectara, again, this is open source. So we're working with a bunch of industry partners to continuously enhance this model. And as many of you know, for example, OpenAI yesterday announced the GPT-4 Turbo. So it'll probably be next on our list to put that and test that as well. But any new model that you guys anybody wants to test with this model, again, you can just download it very quickly from the Hugging Face repository where it stays and run it the same way that Forrest has shown you today. And with that, let's see if there's any questions we can, Forrest can answer on the stream or anything else. I think I would say, one of the reasons we worked on this is because people care a lot about models that hallucinate. I think it's one of the biggest challenges for using LLMs today, where you don't know how much it hallucinates or not. And as an industry, I think there's many ways to fix this, but at least to give people a sense of like, on average, we think this model hallucinates this much. I think gives you a good starting point. For example, Forrest, if you can share the leaderboard again one time,
sure. You
can see that there's I don't know if it was shown quickly, maybe people don't remember, but there's quite a bit of differences there between kind of let's take a look at that for a second. If you look at the models we tested so far, no.
Yeah.
So if you go on the leaderboard, right? So you see GPT-4, GPT 3.5, Llama. If you look down at like Google Palm Chat, it's actually not as good as the others. So there's quite a lot of differences. And I think as more and more models come on board, a new model for Mistral, a new model for Llama, things like this, I think it'll be a very useful tool for people to understand how this sort of ranks in terms of the different level of accuracy, right? And hallucination rates. We have 27% hallucination for Palm Chat. That's quite a bit. And I think I'm sure they're working on fixing that. But that's the example of why this is important.
Okay. Thank you for the answer. And I have...
Oh, you're muted, Alicia. We can't hear you.
Thank you for the answer. And I actually have a question from the chat. So let me just read this. Does the hallucination model offer a means of avoiding hallucinations or just for detecting the output contains hallucinations?
So it just detects hallucination. I think as Forrest shown, you give it the sort of the context, the facts, and you give it the summary, and it tells you whether, a number between 1 or 0. 1 means it's actually really close and not hallucinating. Close to 0 means it's very much likely to be hallucinating. And that's what you get is that number.
One more question I have is, as we know, the industry is slowly moving to the more industry-specific large language models, so the ones that are trained on more specific types of data that can be used for, let's say, healthcare or legal use cases. Are you going to make this model more suitable for specific use cases so you can, let's say, determine best models when it comes to legal tech or best model when it comes to healthcare? Or is it the matter of me inputting the model I want to test?
Yeah, great question. So, and again, I want to be careful with terminology because we have two models here. Like people say, the word model is used in two different ways. There's the model for hallucination evaluation, which we call let's call this HEM. That's this model that we just showed today. And there's the model that in the question was referred to, which is the model, the LLM that's been specific to a specific industry. Let's say a legal LLM or something, or Bloomberg GPT, or was the one that created for finance. So if you take that LLM, any LLM, whether it's for, let's say it's a legal GPT of some sort that you create, you want to evaluate how much that model after being created in this way hallucinates. You can run this HEM model on it. I think one of the things we're looking for, maybe collaboration with other people, other companies, is if you create a model that's specific for this kind of thing, you can also help contribute data sets from the legal space to be able to train the HEM better on these types of data sets. But generally, it should work for any model you want to run this against.
Okay, that's clear. All right. Yeah, I don't have any more questions in the chat. And as always, I just want to ask maybe any future announcement that we can expect. Something next week that we will have maybe talk about.
All right.
Or you don't want to share this?
Sorry, say it again.
That
What
was
was
the
the question?
question. Any big announcement that you're going to have in the near future?
The industry is moving really fast. We don't have, again, we wanted to announce this. This was a lot of work for our team, and we had a lot of announcements, a lot of interest from, as I mentioned, the New York Times covered this, and a bunch of other news agencies. So it creates a lot of things. What's going to happen next? I can't share yet, but this is a very fast-moving field, and there's a lot of stuff happening all the time. So I can't promise you there won't be any good surprises in the next couple of weeks too. It's just the nature of the LM space is very fast. So keep tracking if you are interested. We do have a newsletter for Vectara where we share a lot of our big announcements, and so you're welcome to sign up for that. It's on our website, and they'll make sure that any big announcements we have will come your way. We also tend to announce things on our discussion forums. Those are where you can ask questions, you get help too. But a lot of times there's big announcements topics there, and we tend to share some stuff there as well.
And as a community, would love to be on top of this, so we can already take stuff and work on this over the hackathons. Thank you so much for the announcement, and for everybody that were watching the stream or wanted to watch, it will be in recording, so you can just get back and see how the model works and how you can actually incorporate it into your own projects. So feel free to do so. It will be saved here on Twitch and shared with you on Discord. And for everybody else, I'm looking forward to see you on the Q&A sessions and Vectara office hour to discuss your projects, and have a great hacking.
Thank you.